Now let's go and see the mat foundation. If you go to the mat, right now we have grade beams created. We don't want that, okay? So we can go to the XZ view, repeat the same process. We'll go delete members, okay? And just rubber band across the mat slab, delete all those elements are gone, right? Okay, so let's go to isometric view. Here, this is the slab mat foundation created, the slab created, okay? Now let me go to the XZ view. I don't want these edge columns, right? No problem. We can go to edit, member data, and delete members by fencing around, okay? And I can delete those members. I can delete these edge columns, okay? Those are gone. Then we want to look at the ZY axis, okay? So type in ZY, and we can delete these columns at the edge. And repeat it on the other side, okay? So once that's done, we're almost done with our foundation. Now, again, go in and check for duplication of our floating joints. We can delete those. Any duplication of joints, you have to supply a search radius, okay? So that's solved. Any duplication of members, we don't have any, beams now. So that's our structure with openings. Now, from the geotechnical reports, you might have like a subgrade modulus that you might want to assign to the mat slab. In this case, there is a feature inside GT STRUDL to generate those spring constants based on influence areas of those joints. I'm not going to go through that in this tutorial. Rather, I'm just going to go to create support and releases, and here I'm just going to say that this is 400, this is 500 kips per feet, and this one is 400, and fence around just those node points, okay, and create these supports. So those are my supports created. Good part about STRUDL is it'll allow you to create a text representation of what you've created so far. That's the STRUDL language. It's coming from MIT, and other programs have adopted that language as well. Okay, you'll see that in action now. So if you go to File, Generate GT STRUDL Text Input File, Generate Input File, you can say that this is a tabletop structure. .gti, which is GT STRUDL input file, and if you double click on it, you can see what that file contains, okay? So you might recognize this format. Other programs have adopted this. These are your nodes. Then these are member incidences, plate incidences, okay? And then we have supports, okay? So these are all your supports. You can do groupings and all that to make it more concise, okay? But now what we can do is we can go in and create some loads. So if I go to create loads and go to self-weight, okay? So here I can just say 1, and I'm going to say dead load, and store that. I can go in and generate loads. Now here it's going to include the elements. So what it's going to say is it knows the density of concrete, it knows the thickness of the plates that you've assigned. If we say generate loads, it'll create those loads for me, right? But we've assigned a 3.5 foot thick slab at the top, which we had copied at the bottom. I want that to be 4 feet. So I can go to edit, and go to element data and change that using this fencing option. I can go to thickness, fence around this slab at the bottom, and change that to 4 feet from 3.5. It actually goes in and modifies the loadings also, okay? Why does it do that? Because if I go to GT STRUDL, let's say I'm going to generate my input file again, and this time I'm going to call it tabletop 2, okay? It actually generates a self-weight command for me, okay, which is a general self-weight command. It doesn't store the loads, okay, so it'll recompute those loadings for you because I've changed the thickness of the slab, okay. Okay, so once that's done, we can now run the analysis on this. I'm just going to go in and create two views, okay, just drag and drop. Here is the 3D view of this structure, and this is the stick line representation. I'm just going to make the stick line representation mode active by left clicking on that window, inside that window, then click on analysis, linear analysis, stiffness, standard analysis. It will run the analysis for you. Now, very simple case, but doesn't take a long time to run. You can see that. You can go to results, deform shapes. You can see things like animation. Just set the animation speed to 10 to make it animate very slowly. Okay, so it's a spring supported foundation, right? Later you want to do dynamic analysis on it, but you can go to results, then also go and look at finite element analysis results, contour stresses and displacements. So these are the stresses, but you want to see the bending resultants. Okay, so these are MXX, MYYs that you can use for your design of your slab and your mat foundation. You can design those columns also for self-weight action and so on. Again, this is Ravi Ozarker. If you have any questions about STRUDL, please feel free to contact Hexagon, and we'll be able to help you out. Okay, so this is GT STRUDL 2018 R1 that you're looking at. Thank you and have a nice day. Bye-bye.